screen. So can you see this PDF?
Yeah, we can.
Okay, good. So again, a happy new year. It's kind of a very cheerful climate change, climate risk, and finance, you know. What a deadly combination that is. My name is Gerhard Kling. I'm based at the University of Aberdeen. I'm a professor in finance. This is a joint work with Aravinda Gunchupalli. She is a senior lecturer in global health, also at the University of Aberdeen. And in this project, we look at climate risk and inequality, focusing on a cross-country perspective. So what that actually means is we look at inequality between countries, but not within countries. That's maybe not perfect, but it addresses in particular issues around data availability, and I'm happy to discuss that further. In this very brief talk, I provide an overview of the ideas we are trying to explore. I've talked about the motivation, a bit about theory. I don't go into any detail. I only have one equation. You know, that's nothing for me. So that's just a very light touch discussion. I talk about some initial findings, and I try to conclude. And I'm more than happy to have a discussion about all of these points. Okay. Now, when it comes to inequality between countries, this has been studied quite
Gerhard, we're finally getting, you're kind of going in and out.
History under the heading of fasting debate. Okay, I will switch off maybe my video to make it better. Usually it gets better. Hopefully it's better. So if you also switch off videos, it's sometimes better for our Wi-Fi. Wi-Fi connection today is not fantastic. Now, what this literature basically does is it looks at whether countries are becoming more similar over time, and in particular, whether countries that are less developed experience what is called catch-up growth. Yeah, so do they actually outperform more developed countries? And that is what you call convergence. Now, roughly there are three periods that are discussed in this literature. One is the period before the First World War that witnessed the so-called first phase of globalization, where you see significant integration of markets and convergence. Then the interwar period, where you see exactly the opposite. So you have deglobalization happening, markets disintegrate, and countries diverge. And then you have the period after the Second World War, where again you see convergence. And what is missing in this whole discussion is the impact of climate. And we argue that, in fact, it's likely that there is a significant impact that might influence the importance of convergence and also this whole process. Before I go there, the main driver when it comes to convergence is integration of markets. So here we talk about globalization, economic and financial integration across markets. There are various issues here. I just want to highlight one way to think about this problem. And this is about the relationship between saving money as a country and investing money. If the country is closed, if the borders are shut, you can only invest what you save. You can't invest what you basically consume. So there is a one-to-one relationship between investing and saving. Once the country opens the borders and money can flow across borders, you can deviate from this relationship. And this is basically what is measured in the so-called Feldstein-Horioka coefficient. This measures how much markets are integrated. And we have done some work on integration, and basically what you see in this figure and this is for the European Union and also for the non-European states, you see since the 1990s an increase in integration. Yeah, so if this figure goes down, if this line goes down, it means countries are more integrated, so there's less of a relationship between investing and saving. There is a turning point here, clearly, and this is the global financial crisis of 2008. And since then, actually, you see more signs of disintegration, which would be an issue in particular for less developed countries in terms of catching up and maintaining convergence. So that's the first part of this puzzle. The other thing is climate change. We have done quite a bit of work on this also with Uli. We have done some work on the impact of climate change on finance and economics. The main issues there are number one, obviously, economic activity affects emissions, which in turn, of course, affects climate. I think this is very hard to deny. Of course, some people still do that. So that's one mechanism. But the other mechanism is, of course, that climate change and climate risk in particular itself affects countries in different ways and can have an impact on economic development. And that's the other mechanism. We also looked at other forms of outcomes, not only economic development. So in a recent project, also with Aravinda Guntupalli, we look at health outcomes, looking at mortality in England and Wales since the 1930s and the effect of climate. The only thing I want to mention here, which is quite important because it's overlooked quite frequently, and this is some work we have done here in this fancy graph, what we can see, which is before COVID. Now, COVID, of course, is changing the picture, and it's interesting to debate why. You can see that if you look at monthly mortality since the 1930s, that the short-term cycles, so this is seasonality, is getting smaller. So you have less effect of seasons. So to some extent in this period, England and Wales actually benefited from warmer winters. You see less mortality. However, the tables are turning, and we see this also in the data, because now you see an increased frequency of heat waves and more mortality during the summer. So what I want to stress here is that when it comes to climate change, you will have different effects. You have winners and losers, and it depends very much on geography. And if a country is not in the right place in terms of geography, well, you are exposed, whether you are responsible or not. And that's the main issue at play. Now, in terms of convergence, the mechanism that is driving this is what you call capital accumulation. So basically, to achieve economic growth, countries have to accumulate capital stock. How do they do this? Well, they have to invest. And in order to invest, you have to try to get money from investors. And what investors charge is the cost of capital. And what we found in some previous work, we found that cost of capital goes up because of climate risk. So countries that are in the wrong place and experience significant climate risk, they have to pay about 10% higher cost of capital, which is quite substantial. And these countries very often tend to be less developed. So we will find it a lot more difficult to actually converge to a higher level. So there's a direct link between climate exposure, climate risk, and economic inequality between countries. So that's the main argument. I don't go into these equations. I know some of you might fancy that, but the main thing about convergence and measurement is actually to talk about a way to measure similarity. And this is done looking at the range of values in terms of economic development. Now, in this literature, we look at GDP per capita as a measure for economic development, which of course is flawed. We do some adjustments to that, but basically if GDP per capita across a number of countries becomes more similar, the range reduces, the variability reduces, which means that the measure goes down in value. So that's important to have in mind. Now I show you three figures which kind of summarize a few interesting observations. The first one is about economic development in the very long term. Now, this data is compiled by the Medicine Project, which is quite unique, is collecting and trying to collect data which go way beyond the standard data range for economic development. I'm looking here at a log GDP per capita measure. Now, if you take the log of a time series, if you see a straight line, it means exponential growth. Now, when you look at this figure, it's quite evident that for a very long time, you don't see any straight line poking up. It's pretty much flat. So until about 1800, there was no sustained economic growth. That's the message. Since 1800, you have exponential growth. You see the straight line, that's exponential growth in real terms. So the main takeaway here is economic growth is actually not the norm. If you look at the long term, if you look at human history, it's the exception. So people always assume it's going to happen anyway, but that's not necessarily true if you go a bit back in history. The other point is if you look at long-term climate data, and this is now from Berkeley, which is, I think, the best database on that. We have very good data for the last about 150 years, and before that it gets a little bit more difficult. However, when you look at the data, it's undeniable, of course, that you have an increase in temperature, a deviation from so-called normal range, which certainly sharply increases, in particular since the 1980s. Yeah, that's very hard to deny. Finally, on convergence, the picture is also quite astonishing. And so the data before the 1950s is quite difficult to obtain for, in particular, less developed countries. But since the 1950s, we have quite reasonable data. So what you see in terms of convergence is that this measure increases, which means there is divergence. Yeah, you see this increase in value roughly up to the 1980s. And that means countries in this period become less similar. And that's because after the Second World War, a few countries significantly developed, like in Japan. They developed quite early, then recovery in the case of Europe. But other markets, other countries did not really catch up. But then you have this remarkable sharp drop of this measure, which means convergence from roughly the 1980s, early 80s, up to 2011. Yeah, and that's partly the impact of the global financial crisis and other factors, and we can discuss this further. Now, this is quite remarkable, this significant convergence, which means inequality across countries has significantly improved in this period. And of course, one of the main drivers here is what happened in China. So China reopened the economy in 1978. And of course, then subsequently also in India and other countries, the tiger economies, significant economic development also in Africa, in some countries. So there is actually quite a success story in here. And the main concern now is that convergence seems to stop quite a bit. And this is definitely related to a reduction of integration of markets because of the global financial crisis. Now, the interesting thing, of course, is now what happens next in terms of climate risk, because it's quite hard to argue that it's getting any better in terms of climate risk and potential impact as we discussed on the cost of capital, because more risk is not what investors like. And in particular, the issue, and this is of course also discussed today in more detail, is that many of the countries most at risk don't have adequate insurance markets. So they don't insure that much against potential impact of disaster. So that's another effect which makes these things worse. Fundamentally, if a country has high climate risk and hence high cost of capital, it will be more difficult to accumulate capital, it will be more difficult to grow. And most importantly, and we have done this in some previous work, it will be more difficult to invest in mitigation. And that is actually proven to be effective in limiting the impact of climate risk in terms of the economic impact. So in the end, I conclude with a few observations. So I think it's important to have in mind that economic growth is not the norm. If you look at human history, it was the norm for about 220 years. But certainly not for any longer periods. So actually, it's quite astonishing that you have a sustained period of economic growth. The other note here is that convergence is again not a given. Yeah, so you have periods where you have divergence, in particular in the interwar period, but also from 1950 to roughly 1980, and then you have a sustained period of convergence, but it's very likely it's about to stop. And one factor is definitely the global financial crisis, but there are also other factors at play, in particular political factors, but we argue also climate risk as additional burden for some countries. There is some good news, because it's always nice to end with some good stuff as well, in particular early in a new year. Of course, technology is changing as well. And when you look at the link, and we have looked into this between economic growth and CO2 emissions, of course, this link is getting weaker. And there are significant improvements, in particular in the case of China, which will reduce the negative impact of convergence on climate change. So the main point to make is that in the end, it's a bit about fairness, because the countries most exposed in terms of climate risk are the ones that will actually be punished in terms of economic growth. But they're not really the ones responsible, because they did not contribute much to global emissions, in particular historically. So if you start accumulating emissions over time, for instance, it's quite clear that the countries most responsible are not necessarily the ones that have to pay the price. I think it's important, in particular as an academic, to also be very honest about data quality and the models we use, and I think it should be discussed openly, because it's definitely a matter of truth that data quality is only really quite solid, in particular for the last 50, 60 years for most countries, with some exceptions where it goes back about 150 years. Before that, there is a significant degree of uncertainty. Finally, of course, we all know this, but it's always good to repeat that. There is no really straightforward, easy solution, quick fix. You always have hard trade-offs. And the trade-off, in particular, when it comes to convergence, is if you slow down convergence, so basically restrict economic growth in less developed countries, where you also pay a price. It doesn't come for free. But of course, there are challenges in terms of contribution to climate change. So that's basically what I wanted to cover. There are quite a few references. I'm also happy to share this document if you find it useful. It's still work in progress. We have done a fair amount of modeling, quite some exporting going on in Python, if anyone is excited about that, which we will also make public once we get rid of all the bugs, and there are quite a few. So thank you very much. I'm happy to take questions.
Brilliant. Thank you, Gerhard.